Welcome to This Explainer. Today, we're tearing down the walls to look at the invisible architecture that literally brings our entire digital world to life. Whether you're working on a massive desktop tower or just scrolling on your smartphone, there is a fascinating, highly complex ecosystem running just beneath the surface, making every single click possible.
Picture this. You just dropped a ton of cash on the absolute most cutting-edge computer on the market. You plug it in, and nothing. The screen is completely blank. Why? Because all that physical hardware, the fancy chips, the crisp screen, the mechanical keyboard, is practically begging for instructions. Without those instructions, you're basically staring at a very expensive, high-tech brick sitting on your desk.
So here's the deal. Software is the actual brains of the operation. It's the specific set of instructions, the programs, and the raw data that actually tells your computer how to do its job. Think of it as the ultimate translator. It bridges the massive gap between a chunk of metal and plastic and the actual tasks you want to get done, providing a platform where you can actually interact with the machine. Here is our roadmap for today's explainer. First, the brains of the operation. Second, system software, the backbone. Third, application software, or your tools. Fourth, open versus closed source. And finally, mobile and web apps. All right, let's kick things off with part one, the brains of the operation, and its two main branches. You can basically split the entire software universe right down the middle. On one side, you've got system software. That's the invisible backbone overseeing and supporting all the core computer functions. On the other side, application software. These are the specific, tailored tools designed to meet your actual needs. It's kind of like this. System software is the city's foundational road maintenance crew, while application software represents the specific cars you choose to drive on those roads. Moving right along to part two, system software, the backbone. Now, system software isn't just one single magical program. It's a whole crew of dedicated workers keeping your environment stable. We're talking about managing hardware resources, organizing your messy files, and keeping the system from crashing. It branches out into operating systems, utilities, programming language translators, and device drivers. Let's zoom in on the big boss first. The operating system, or OS. You literally cannot run a computer without it. Think of the OS as the ultimate traffic cop. It's the very first software loaded into your RAM when you hit the power button, and it doesn't clock out until you shut down. It acts as the core interface, controlling the hardware and setting the stage so you can actually get to work. Whether you're rocking Windows on your PC, macOS on your Apple rig, Android on your phone, or maybe you're a fan of the Linux Penguin, they all do the exact same vital job. You simply cannot operate your device without this traffic cop directing the flow. It's the platform that makes absolutely everything else possible. But hey, the OS doesn't do it all alone. Enter utility software. You probably recognize a few of these, right? These are your digital janitors and mechanics. Whenever you need to recover a lost file, zip up a huge folder with something like WinRAR, scrub your system history with CCleaner, or hunt down nasty malware with Avira, that's utility software rolling up its sleeves. To wrap up our tour of the system backbone, we've got to give a shout out to two huge unsung heroes. First, language processors, stuff like compilers and interpreters. They take the high-level code that human programmers write and translate it down into the raw machine language the computer actually understands. Second, device drivers. You know when you buy a brand new printer and you have to install that annoying setup package? That's a driver. It's basically a custom instruction manual that teaches your computer exactly how to talk to that specific piece of hardware. All right, on to part three, application software, your tools. So there's a really important shift to understand between these two halves of the software world. System software, it manages resources, it's written in low-level code, and it's capable of running entirely on its own the second you power on. But application software is totally dependent. It uses high-level language and only wakes up when you specifically need it. It starts when you click it, terminates when you close it, and it absolutely relies on that system software foundation to even exist. Application software is where you, the user, finally get to take the wheel. These programs are custom crafted for your specific everyday tasks. Typing up an email, editing a killer photo, rendering a new design, cutting a video, or writing code. All of that is you actively using application software. And within this application world, you've generally got two distinct flavors. First is package software. Think MS Office, Maya, Zoom. These are off-the-shelf, ready-made solutions built by massive companies for general audiences to do general tasks. The second flavor is customized or tailored software. This is highly specific, bespoke stuff built for one single organization, like a custom billing system for a local business or specialized management records for a hospital or school.
Let's pivot to part 4, open versus closed source.
This is where we get into a major philosophical and legal debate in the tech world. Who holds the keys to the kingdom? On one hand, you have open source software. The underlying source code is right out there, publicly accessible on the internet. Anyone can view it, tweak it, and use it. On the exact opposite end, you've got closed source or proprietary software. Here, the code is locked down tight. You usually have to buy a license to use it, and you absolutely cannot peek under the hood to change how it works.
We see these two completely different philosophies clashing every day. For the community-driven open source side, you've got massive projects like Linux, Java, and the Firefox browser. Conversely, holding down the proprietary fort, you've got closely guarded commercial giants like Windows, Skype, iTunes, and macOS.
Now, neither approach is perfect. They both have big trade-offs. Open source gives you insane freedom and flexibility, and it fuels rapid innovation because literally anyone on Earth can contribute. Plus, it's usually free. But because the code is wide open, hackers can study it too, meaning security is handled very differently. Proprietary software, on the other hand, limits outside innovation and usually costs money, but it offers tight, exclusive control over the whole ecosystem. If something breaks in a proprietary system, you've got to wait for the vendor who built it to push an official fix.
Finally, let's wrap up with part 5, mobile and web apps. Over the last decade or so, we've witnessed a massive shift in how application software is actually delivered to us. First, mobile apps. These get installed directly onto your phone or smartwatch, and they're specifically designed to tap into your device's unique hardware, like the GPS, the camera, or the touchscreen. But then you have web apps, which are all about ultimate convenience. Think Gmail or Google Docs. You don't actually install anything. They run entirely on remote web servers over the internet, and you just access them through a browser, which means you can jump on any device, anywhere with internet, and pick up right where you left off. Understanding this vast, invisible architecture, from the deepest foundational operating systems up to the specific application tools you click on every day, and knowing whether their code is open or closed, it's incredibly empowering. It lets you navigate your digital life not just as a passive consumer, but as an informed participant. So I want to leave you with this. Next time you open your favorite app, ask yourself, are you just a user or are you in control of the code? Thanks for hanging out with me for this explainer, and keep exploring the systems that run our world.